sorry. And I do have to get through quite a bit of content. Oh, something I need to talk to you guys about. We just had a big unit test. You're not going to be quizzed on Monday next week. You're going to be quizzed Thursday. Okay, so just so you know, like we're going to cover content first, and then I'll quiz you on your 10 a week on Thursday. Did I give you guys your 10 a week yesterday? I haven't printed it for you. You guys, it'll post in Google Classroom. Hold on 1 second. Yes. Or no, I gave it to you guys. Didn't I post it early so that you guys could do the trig questions that were in the 10 a week? I'm pretty sure I did. Let me just double check. So when I'm looking here, I posted, so earlier this week, I posted this April 1st. So I posted it early just in case you guys wanted to do practice before the big test. This is the quiz that I'm basically using, or this is the 10 a week that I'm using to model your quiz next week, okay? So just kind of like, these were all trig questions that people could have done if they had wanted to, but this is the 10 a week. So I didn't print because some people just would have used it online at home before the unit test, so I did not print it for you. If you really want me to print it for you, let me know before Monday and I will, okay? So this will be your 10 a week quiz on Thursday of next week, okay? So when you look at your formula on your formula sheet, this is the only thing you get for exponential functions. This is your final amount of whatever it is we're talking about. Now this t represents your total time to get that y value. Like it's the total time that's going to take for you to get that y value. Your a is your initial amount. Of whatever it is we're talking about. Now we learned that by definition an exponential function has to have a base that's positive and it can't be 0. If your base is greater than 1, we're going to grow. And if your base is between 0 and 1, it's going to be a decay function. Now directly linked to the b value is going to be your period. So there's going to be some sort of talk about growth or decay, and then there's going to be right next to it, there's going to be a time frame connected to that. That's called your period. So period is linked to b, and the t value, your total time, is linked to the y value. You're going to find this actually a little bit refreshing in comparison to trig. This first little bit, you're going to be like, oh, okay, this is super manageable. Trig was super complex. This is going to be a little bit more straightforward. Basically, you have 5 variables, and you're going to have to find, you're going to be given 4 parts, and you're going to have to find the 5th part, whatever that is. So this is just one quick example that we had left here. It says the population of rabbits in a park is increasing by 70% every month. Now last year we talked about, when we did geometric growth, we talked about increasing and decreasing. When you're dealing with an increasing of 70%, that means your b value is going to be 100% plus your 70%, which means my b value is 1.7. Remember, by definition, if we're increasing, the b value has to be greater than 1. And how do we make it greater than 1? We add it to the 100%, or we add it to the 1. So your b value is going to be 1.7. And we actually did this a lot in the first unit in 20-1. Like we did a lot of vehicle depreciation and appreciation. So it says, what will the base be for the exponential function that represents this scenario? The base will be 1.7. Then it says, write an exponential function that represents this scenario. Okay, so now this is the twist. It's increasing by 70%, but it's not per year. It's every 6 months. There's a time frame directly connected to the rate of growth. That's your period. Okay, that's your p value. So right here, this is p. And then presently, there's 200 rabbits. Guys, that's our initial amount. That's our a value. So it says, write an exponential function that represents this scenario, where p is the rabbit population and t is the time in months. I'm going to put all the details together. So population as a function of t is equal to, I'm starting with 200, My rate of growth or decay is 1.7. It's specifically increasing, so it's got to be above 1. And then I don't know my t-value, but I do know that my period is 6. So every 6 months, we're going to have 70% more. Now it says how many rabbits will be there in 15 months. Guys, this is a t-value of 15. You should show, using function notation, that you've substituted the 15 in, and then get my rabbit population. Can I get someone just to fire that into their calculator quickly? Did you get that? So we would go 754. Okay, so in 15 months, the rabbit population will be 754. And you always answer in context. If you're talking about rabbits, you have to say rabbits. If you're talking about fish, you have to say fish. So I just want to show you guys, and we had just done this 2 days ago. This is homework that I'll be checking on Thursday of next week, okay? But we stay on top of it. We do it every night. We come with questions the next day. Okay, do not let yourself fall behind. So this was the formula that we talked about when it was something that was decaying. As soon as you see the word decay, you know your B value had to be between 0 and 1, right? And specifically, this had a half-life of the time that's directly linked to your rate of growth or decay, that's your period, okay? And then when we're looking for the final amount, we're given a total time. So this is just your first assignment, and it's just your base entry level, like this is exponential functions. What critical feature does every exponential function have? Like when you look at the first page, we graphed a few exponential functions. What critical feature did every exponential function have? Do you guys see that every exponential function had a horizontal asymptote? Why is that? Because if the base is greater than 0, we can never take a positive number and take it to an exponent and get 0. It's impossible. We can get really close to 0, but we never get that 0. So we kind of explored these exponential functions. Now guess what? We get to transform them. So by definition, your transformations that you guys get on your formula sheet, they look like this. And we're back to H's and K's. We're not doing C's and D's anymore like we did with trig functions. So what you need to recognize is the base of the exponential function is not a transformation. That's just the base. It's not an A, it's not a B, it's not an H or a K. So for example, if my original exponential function was 2 to the power of x, if I were transforming it, the A would be the coefficient, the 2 is still the base, the B and the H follow the x up into the exponent, and then the K is a big value again. So you need to know where the B and the H and the K and the A actually land. The 2 is not a transformation, it was part of the original function. If I wanted to do like y is equal to 3 to the power of x, in transformation form, it would be A times, so coefficient. The power is still base 3. The B and the H follow the x up into the exponent. And remember, by definition, the base is always greater than 0. So, same idea, right? A is the vertical stretch factor. If A is less than 0, then there's a reflection across the x-axis. This is written, y equals negative f of x. Here's the important to just exponential functions. So I'm going to come back to the highlighted stuff. Your B value, 1 over B, is the horizontal stretch factor. If B is less than 0, then there's also reflection across the y-axis. We can reflect across the y-axis for these guys. H gives the horizontal translation. The function is moved to the right or to the left. X minus H means right. X plus H means left. K is moving it up and down. Now guys, we had a horizontal asymptote at y equals 0. We can't stretch 0. When you multiply 0 by anything, it still stays 0. So you can't stretch 0. But what can we do? We can translate it up or down. Okay? So what happens here is you're going to recognize that your K value, whatever your K value is going to give you the equation of your horizontal asymptote. Okay? Now normally, your graph is like quadrant 2, quadrant 1. When you look at the first page, it was quadrant 2, quadrant 1, and we were above the asymptote. If we have a reflection across the x-axis, okay, if we reflect across the x-axis, instead of y is greater than k, it's going to become y is less than k. This is the stuff that you memorize specific to exponential functions, okay? So this would be like, okay, I'm putting this in my notes. This is the detail that I'm not going to come back on Monday not knowing this. I'm going to make sure that I review my notes. I'm going to make sure I know this before Monday, because Mrs. Akira is saying, like, if I do this in small increments, it becomes easy. If I try to learn it all in one shot, it's hard. Okay. We know the mapping, and now all we have to do is just kind of connect this. Oh, all horizontal translations, horizontal stretch, reflect across the y-axis, horizontal translation will be found in the exponent, right? To find x-intercepts of the function, you have to find the zeros of the function. To find the y-intercept, we trace zeros. So these are just calculator buttons, but we're going to have algebra that's going to go with this. Okay. If our base function is y is equal to 4 to the power of x, and it turns into y is equal to negative 4 to the power of x, what transformation has been applied? Another way of writing this would be negative 1 times 4 to the power of x. Guys, my base was never negative. It was the coefficient that became negative. If a is less than 0, how do we describe that? Yeah. Reflection across the x-axis. Guys, so this is a right here. How about this one? When you look at it, it's a negative 1 attached to the x. Which one would that be? Do you guys see the reflection across the y-axis? Okay, so this is going to be b. This is a large negative 2. It's a k value. How would you describe it? Do you guys see the translation down? Now here's the detail I need you guys to attend to. Y equals negative 2 is your horizontal asymptote. For all these other ones that don't have k values, the horizontal asymptote would have been the x-axis. It's just y equals 0. There's no other k value. But this is what I need you guys to start recognizing. The k will always give you your horizontal asymptote. The sooner you guys memorize this, the better off you are. But you can always look at them in your graphing calculator. And then this would be a translation right. Are you guys okay with that translation right? And this should feel like entirely review, particularly if you guys have been doing your 10 weeks. Transformations are like quick and easy now, right? Okay. This is your basic y is equal to 1/3 to the power of x. Let's just really quickly confirm why this ordered pair is what it is. If x is equal to negative 1, then y would equal 1/3 to the negative 1. And then using our exponent laws, this becomes 3 to the power of 1. And that's why the ordered pair, 1 and negative 1 and 3 exists. Like, you guys get that, right? When x is equal to 0, guys, what's 1/3 to the power of 0? Right? And then we know that 0 and 1 exist. And then if I said x is equal to 1, so you have to feel comfortable with your exponent laws. And then that's why this is 1/3. Okay? So this is your most basic. Y is equal to 1/3 to the power of x. That's the function there. And now all I want you guys to do is I want you guys to see if you can, without your graphing calculator, could you match the graph equation to the graph itself? Like, could you do that? sometimes I think that the best strategy ever is just to find the y-intercept for each equation and see which one gives me the right y-intercept in the graph. Because when you actually compare them, this is a y-intercept of 0 and 2. This looks like it's a y-intercept of like 0 and 9. This looks like it's a y-intercept of 0 and 1. This looks like it's a y-intercept of 0 and -1. If there's 4 different y-intercepts, and when I say y-intercept, you insert x equals 0, could you very quickly find the y-intercepts for each of these and be able to narrow down the graph? Can you guys do that now? And all I'm doing is algebra. I'm just inserting zeros in, and then I'm solving for the y, and I'm getting ordered pairs. And once I get those y-intercepts, I know exactly which graph is which, without even having to analyze the transformations. Some of you guys are like, you know what, looking at the original graph, I could see the transformations. And when I could use the transformations for that, that's great if you can do that. I just prefer to be like have a concrete ordered pair. I don't want any ambiguity at all. I can see that this graph right here have a y-intercept of 0 and 9. So this one must be 1/3 to the x minus 2. All that happened was the graph on top was moved to the right 2 units. Can you guys imagine that? Move to the right 2 units. This one has a 0 and 2 y-intercept, which means it must have been this guy. If I were to take the negative sign to the base, it would become 3 to the power of x, and this would become an increasing exponential function. Do you guys kind of see that? Or you can see it as a reflection across the y-axis. This one has a 0 and 1, so this must have been my 1/3 to the 1/2 x. This one has a 0 and -1. This one had the reflection across the x-axis. Yeah? Okay. So let's just see if you guys remember mapping. Remember that the mapping is the key to success moving forward with transformations. So remember that the 5 is not a transformation, it was the original function. So the graph of y is equal to 5 to the power of x is transformed into this. What would the mapping for the x be? Like just looking at the x, what's changing the x? How would you describe the transformation that's being applied to the x values? What would you say for the x?
X plus 4, is moving to the left 4.
Left 4 would be x minus 4, right? When you say left, it's, yeah, okay, yep. So the x plus 4 in the equation becomes x minus 4 because we're going left 4. What would the mapping be for y? Remember, y is the easy one. It's just going to be your a and your k, right? So this just becomes -1/2 y minus 6 when I put them together, this is my mapping notation, x minus 4, negative 1/2 y minus 6. And then all I want you guys to do is I want you guys to come up with what these ordered pairs' final output would be, right? So negative 1 minus 4. And we end up with negative 5 is the x value. Negative 1/2 times 1/5 minus 6. It's negative 6 and 1/10, but what is that? Is it negative 61 over 10? These guys follow through. Do the next few ordered pairs. You guys get negative 17 halves here? Yeah? Okay. And could you just fire this into your calculator? Absolutely. And your calculator will give you the order of operations. You don't necessarily have to do the mental math on that. And then again, 2 minus 4, comma, negative 1/2 times 25 minus 6. And the final output, negative 2 Did you guys get negative 37 halves for this guy? Perfect. Okay. So now, okay, when you interpret this, when I look at the equation, do you guys see that there's a reflection across the x-axis? Okay, what does that mean? If you were to graph your most basic y is equal to 5 to the power of x, it would look like this. That's what y is equal to 5 to the power of x would look like, right? And it would have a horizontal asymptote at y equals 0. What happens to this guy? The asymptote has been moved down to negative 6. We now have a negative 6 asymptote. So y is equal to negative 6 is now going to be your asymptote. And then, because we reflected across the x-axis, instead of curving above the asymptote, we're going to curve below the asymptote. So this guy looks like this. Do you guys see that? The k value and the a value will change your range, and they will change your asymptote. Okay? So when you're thinking about your asymptote, usually your equation of your horizontal asymptote is, and you have to give it to me as an equation, you can't just say k, is y is equal to k. In this function, the k value was 6, so the asymptote becomes y equals 6. What's the range? Your a is less than 0, so your range is going to be y such that y is less than 6. Y is now in the real number system. Instead of curving above the asymptote, because of the reflection across the x-axis, we're going below the asymptote. Can you guys get your heads wrapped around that? And then it would just be silly of me not to just type this in and see what it looks like, right? So what was the equation? Y is equal to, it was like negative 1 divided by 2 times 5 to the power of, this is old calculator, so I have to use brackets, x plus 4, close the bracket, and then plus 6. Was this one? Was it -6? Just teasing. That was -6. We did have a minus, right? Yeah, minus. So we can actually see there's still going to be a y-intercept. I could algebraically determine the y-intercept. I think we actually did. No, we didn't. Just teasing. We don't have a y-intercept over there. But I can see that there's an asymptote and we're dropping below. The reflection across the x-axis just says instead of being above, we're now below. So the way we describe this in behavior, we start in quadrant 3 and we're going to eventually finish in quadrant 4. It's an XER. There's no vertical asymptote. Okay? Okay. All I want you to do is give me the function. Once you see the verbal description, give me the function that corresponds with that. Remember that the 0.5 is the base of your function. You don't mess with that. Make sure your b value is factored out. Your b value is negative. If we're going 4 units left, that becomes x plus 4 in the brackets. And then we're going 3 units down. Did you guys get those transformations? Okay. Now, just a quick add-on. 2 critical features that will change based on the transformations will be the horizontal asymptote. Guys, what's my horizontal asymptote on this? And you know that there's ways that I'm going to ask the question, so you're not going to be able to look at it in your calculator. Where's the horizontal asymptote? Booyah, where is it? Y equals -3. You're memorizing that today. Guys, what's my range? I know that the asymptote is basically going to tell me where I can't touch. So I have to get infinitely close to that asymptote. Am I above the asymptote or am I below the asymptote? Santi, would I be above the asymptote or below the asymptote? We're above. Why? Because the a value was positive. We didn't have a reflection. So this becomes y is greater than -3. Now, you can't say or equal to, because then you said we started at -3 and it was actually a start point. It's an asymptote. We're infinitely close to it, but we're just not equal to it. Okay? Can I get you guys to write this one with the transformations in order? I'll get you to do the mapping as well. So we're going to write the mapping with that one too. And people still get this wrong, guys. If you're going across the x-axis, you're changing y, right? If you're reflecting across the x-axis, that means your a is less than 0. Be careful. Don't make it b is less than 0. Horizontal stretch by a factor of 1/2 means that in the equation, we take the reciprocal of the b value, the reciprocal of that horizontal stretch. So your b value is 2. If you're reflecting across the x-axis, you're going to impact y's. A and k change y's, and then we're translated 7 units up. Okay, if I were to say give me the mapping, what would the mapping be? Write it. Remember the words and the mapping, those are buddies, like they're the same. So if I say 1/2, then this becomes 1/2 x. And then we have -y plus 7. And then the 2 critical features. I need horizontal asymptote and I want the range. So horizontal asymptote for this guy. Stein, what do we got? Y equals 7. Got to give it to me as an equation. Y equals 7. The domain is unlimited. There's no restrictions on x. So if you want to just say x such that x is an element of the real number system, that's great. And then your range, guys, what do we know about the range? I know that a was less than 0, so we have this asymptote at 7, and instead of being above the asymptote, because there was a reflection across the x-axis, we're below. What's the range going to be, Zach?
Y such that y is less than 7.
And y is an element of the real number system. There's your critical features for exponential functions. And that's pretty much it. There's no like period and midline. And by the way, boy, did you guys ever rock trig functions. Like I honestly, like you guys did so well with trig functions. I couldn't be more proud of you guys. Like amazing. Okay. We are going to use our calculator on these ones, but I'm actually going to show you that you could probably find them algebraically. I wonder if we're going to get through. Okay. Every exponential function, x can be anything. There's nothing that says x has a restriction, which means the domain is unlimited. So I'm going to just write this as negative infinity to positive infinity because I want you guys to feel comfortable with both interval and set. We know that every domain of every exponential function is always going to be unlimited. Now, what's the equation of the asymptote here? Do you guys see that it's going to be y equals 2? And now when you interpret the range, I see that a is less than 0. So I know that my range is y is less than 2. What would y is less than 2 look like in interval notation? If your a is negative, then the sign will be y is less than, not greater than. Brian, what would that be in interval notation?
Sorry, I just have a different notation.
Okay, so you just have the y is less than 2. How do we show, okay, so if you could imagine, okay, here's my y is equal to 2. And if I know I'm below this, we start at negative infinity and we make our way all the way up to the 2, but we don't include it. Do you guys kind of see that? So in interval notation, this one's easy because it just parallels with like, oh, if a is less than 0, y is less than 2. But what if it gives it to you in interval notation? You just need to know that you're going from negative infinity up to the 2, and you're not going to include the 2. Does that look okay? Okay. When I say x-intercept, what are you thinking? Y is equal to 0. So let's just see if we can do some algebra on this and see if we know how to figure out the x-intercept algebraically. If we want to use the graphing calculator, we totally can. What was the equation, Hannah? Can you just read it to me?
Negative 6 times 3x plus 2.
X plus 2, like this?
No, to the
Okay.
k value.
Perfect, thank you. Okay, let's see if we can do the algebra to solve for x. You might not have all the skills to do the algebra, but I'm pretty sure I set this up so that you would. If I wanted to isolate for my power here, I'd move the 2 to the other side first. Are you guys okay with that? And then I would divide by the negative 6. Guys, what's negative 2 divided by negative 6? What would that be as a fraction? Do you guys see that it would be 1/3? Guys, what must the x be if 3 to the power of x gives me 1/3? What is it? It's totally negative 1. Do you guys see that intuitively? That must have been a negative 1. Because 3 to the negative 1 would give me the 1/3. So then I can see that x is equal to negative 1, and I actually had the algebraic skills to solve this one. You don't have the algebraic skills to solve all of them, but this one you should have recognized. Oh, this is a negative exponent. What would that negative exponent be? Right? Some people would bring this up and call it 3 to the negative 1, then equate the exponents. We're going to get there. What about y-intercept? When I say y-intercept, what are you guys thinking? Could we figure this out? What is it? Y is equal to negative 6, 3 to the power of x. Is it plus 2 or minus 2? It's plus 2. If x is equal to 0, what does this become? Negative 6. Guys, what's 3 to the power of 0? Because you would do order of operations on this. What's 3 to the power of 0? 1. What's negative 6 times 1? What's negative 6 plus 2? Negative 4. Can you guys do this? Okay, so I just did all the math, and I found all the critical features, and I have a really good sense for what this graph looks like because I'm practicing all the math that goes into it, and you have to be smarter than your calculator. If I take a look at this guy, and I'm even going to use this old, nasty, been through the ringer calculator, okay, and I take a look at this function, I can see my asymptote at 2. And if you can't totally tell, if you just push the trace button and you just want to look at, okay, well, what y value am I getting really close to, but it looks like I'm not quite touching it. Like, and you can see that you're approaching the 2, right? I can see that I'm going from negative infinity up to the 2. So just know that y is less than 2 is the same as negative infinity up to the 2. This function goes on forever. When I want to find my x-intercept, I go second function calc, 0, and I'm going to go to the left of my x-intercept. So to the left would be like negative 2, to the right would be 0, and I push enter. And I would like, so Adelaide told me it was x equals negative 1, and she was right. And then if I trace 0, I end up with that 0 and negative 4, right? What are you learning today? You're learning about where the asymptotes can get transformed and how that impacts the range of an exponential function. Okay, I did assign homework from 7.1. I'm not assigning homework from 7.2 yet. Come on Monday with questions, guys. Do not wait till the day before, okay? If you want to review your test